Petri Dish is a product of Petri Dish Media, all rights reserved. All characters during the show, such as Donatella Iglesias, Jimmy Coconuts, and Tyler Jerry, are copywritten and are satirical. Any similarity to any persons living or dead is completely coincidental. Petri Dish is a science comedy podcast and should not be used as medical advice. Do not get medical advice from a podcast.
And therefore, as a free man, I take pride in the words, Ich bin ein
Science! Science!
I know the human being and
Science!
can coexist peacefully.
This was thou findest.
Hey guys, this is Petri Dish. I'm Sean.
I'm Nathan.
And today's topic is epigenetics. It was kind of brought to us by our guest, Lily. Hi, Lily.
Hi, guys.
So, Lily, what got you kind of interested in epigenetics in the first place?
Yeah, so years ago, we were watching the show Orphan Black. And, I mean, if you haven't seen it, spoiler, I'm going to talk a little bit about what the show is about. But basically...
Earmuffs.
Yeah, trigger warning.
Yeah, trigger warning.
I haven't seen it!
But sort of the premise of it is that there are these 6 clones. And so I won't go too deep into it, but at one point in the show, one of the clones, who's a scientist, mentions the word epigenetics. She jumps up and she says, the epigenetic implications of this are just crazy. And Sean
jumped up too.
Basically,
He's like, it is crazy.
You know, it does that thing where he's just kind of like nodding to himself because something was good, you know, and he's like, I can't believe that they used that correctly. So I wanted to know what epigenetics was, and so he explained it to me, and I thought it was really interesting. One of the things is that, you know, these are 6 clones, so they have the same DNA, but they all look different. Obviously their personalities are different, but like one of them wears glasses, but the others don't.
One of them is Rami Malek, right?
One of them is Rami Malek, yeah. So
that was right?
He's got a lot of range.
I thought he was Freddie Mercury. Wasn't he busy?
So it's like, so they're clones, but it also kind of makes you think about like twins, how twins technically have the same DNA, but they can look kind of different and they can be really, really distinct.
Right, yeah.
I don't talk to twins.
Well, no, it's how one twin is always evil, you know? It's
Right.
basically that.
Right.
Yeah, like you and me. We're so different, we're 4 years apart. There's a lot of epigenetics there.
What the fuck?
Yeah, so then Sean explained what epigenetics is, and it's like that there are things in your environment or things that you could be doing or ingesting or exposed to that can change the way that your DNA is expressed. And it's like the nature versus nurture thing. So like you have all your DNA when you're born, but there are things that can change the way that it's expressed and that could change you, and that those changes could actually be passed on to your kids. So I thought that was pretty crazy and pretty revolutionary, so I wanted to learn more about it.
Is this why, like, I eat butter and I get big, but, like, there's that one Italian village where everyone's always eating butter and pasta and they're all skinny? Is it epigenetics?
No. I think that, right? Like, I think that's what epigenetics is.
Those lucky fuckers!
I do like
Maybe
how...
it's just genetics? I don't know.
As Lily was describing how your life choices can affect you and maybe your kids, your
Just
face
like existential.
more and more horrified.
Christmas past, dude. Guy Pearce haunts me.
He haunts me too. I don't know.
Yeah,
There's
he's so
something off
haunts.
about his face. I
Can't tell if he's handsome or scary.
know.
Which is my kind of man.
I feel the same way.
Well, that's why Henry Cavill was never my thing as Superman, but now he's the Witcher and he's all weird looking. He's so hot. And we tried watching it last night. Stacey couldn't watch it. I was like, what do you think's happening in the story? She's like, oh, ass. It's like such high-waisted leather pants and just like, flip! It's like so much calisthenics just like in that butt. Okay, we're derailed a little bit.
Well, I don't know, because maybe his butt is also due to epigenetics. We don't know.
Is just working out epigenetics now?
That's a good question, Nathan.
That is a good question.
Maybe we'll get into that a little bit
I got a good question.
I think actually, while Lily was talking about this, she kind of brought up 2 ideas. One of them was our environment can influence how our DNA gets read and how much it gets read, right? Yeah. And then this other part, which is maybe it can get passed down to our kids.
Right, that's the crazy shit. Because, like, I know I do a lot of LSD. And, like, I know some stuff is wrong now. But, like, the idea that LSD is like, whoop, right in the baby, that makes me worried.
So, I think that this episode is going to be about what epigenetics is, sort of from a definition perspective, but then also the different facts that we do know about how epigenetics influence your DNA and what gets expressed, and then how much truth there is to the idea that you can pass it on to your kids.
Okay, guys, let's get right into it.
All right, so to get into the idea, sort of more of the details of what epigenetics is, we need to start out with what the genetics is, and then we can add the epi part on top of it. So that's going to kind of start out with the central dogma, which is something I brought up in the Origin of Life episode, and you got really antsy about, because I said dogma. You started getting real Catholic.
Yeah.
And twitchy.
Science is Masonic.
But the central dogma is the idea that you have DNA, and that kind of holds on to the info, and then it gets transcribed into RNA, and then that RNA gets translated into protein, and like protein does all the shit.
Right. This is the basic religious belief that scientists cling to.
Yeah, more or less. And so there's this kind of the separation of powers. DNA holds the information, and RNA transmits it.
And Mitch McConnell makes sure the RNA can't transmit it. All right? It's a partisan affair.
They're all sitting on his desk.
Yeah.
And then the proteins actually do the work. So the thing is that for the most part, the cells in your body all have the same DNA, but we have really different kinds of cells.
Right. That's why Osmosis Jones looks different, sounds different than like some random janitor like cell that gets killed in the first act.
Was it even really that good a movie? Why is it stuck so like deeply into you? It's like Osmosis Jones is deep inside you.
You're not my therapist. Back off. I don't want to talk about how Osmosis Jones is deep inside me.
Yeah.
Okay, don't want to talk about it.
Oh, no.
Unfortunately, in this case, you are correct. You are correct. That is an example of what I was talking about, which is that different cells have different jobs. Even though they have the same DNA, they end up acting differently from each other. And so it can't just be a question of whatever your DNA is directly affects and directly dictates how your cells are going to end up, how you're going to end up, right? It kind of ends up being this nature versus nurture question. Throughout your life, as you're living your life, your cells they're going to get little mutations here and there to your DNA. They're going to change your DNA a little bit. And sometimes that turns out badly, like cancer, from our cancer episode. But most of those mutations are just going to happen to you, your cells, not really to your kids. Because to get to your kids, the mutations have to happen in your germ cells where you're making the little spermies or the eggs.
Why are they called germ? I thought germs were bad.
Germ is like germination. It's like life creation.
Oh, that's why germs are called germs.
Yes.
Because they go bloop, 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 and there's more of them, right?
Yeah. Good job, buddy.
Wait, so what you just said about epigenetics, you said that there would have to be changes in the germ cells in order for that to be passed on to your kids. So you're saying there's nothing I could do. There are no like dietary changes or anything that I could do or be exposed to that would change my kids. I can't make my kids like become models or something. Like,
you eat a lot of quinoa.
That's actually a really interesting question because the answer is maybe a little bit different for men and for women. Because women, for the most part, a lot of their eggs are kind of developed up to a certain point when they're a fetus. And for dudes, we're like constantly remaking sperm. So actually, your window to impact your eggs or sperm is very, very different for women and men. For dudes, like, if you're smoking cigarettes your whole life and that's putting chemicals all throughout your body, including down to your balls, then that might actually change your sperm.
Especially when you vape down there.
Yeah, you mean like with your penis?
Yeah, that's like a new thing.
Oh, yeah, okay.
E-peen.
like vodka tampons?
Yeah, exactly.
That's like what's on the streets right now?
Yeah, e-urethra.
So the thing is that for women, for effects to happen to your eggs, it would have to be things that's happening to you while you are a fetus.
Oh, you're so mansplaining. Not even when you're trying. It's just your mouth, your open mouth.
So, yeah, it's more likely that your mom's choices while pregnant might affect your kids.
That's interesting.
Always burdening the ladies.
Yeah, right. This guy. Am I right?
That's what. Yeah.
Although I mean, if I'm taking this correctly, it's really more guys' life choices that can actually impact germ cells, right?
Well,
In fact, it has almost nothing to do with the girl. Her like germ cells. It's like not even impacted by her life decisions. Maybe her mother's, but like okay, but like throughout the life, it's the guys who can whack up their sperm.
Yeah, guys get way more chances at bat to mess things up.
Isn't male spermility going down?
Yeah, the spermulation
you
index.
jack off enough, you use it up.
Okay, let's not make personal attacks on me, Lily. No, I mean it's funny because we were just watching this YouTube video about otters, and otters are getting jacked up because like their sperm is no good no more.
Yeah,
and the lady just offhandedly mentioned like just like dudeism, and is that true? Is there like in the West or in the world is like male sperm getting less virile?
So the answer to that question is probably yes.
Is it microplastic? Like little microplastics hitting up against the sperm?
Yeah, they can't swim straight very well because they keep bumping into microplastics. So sperm count generally seems to be lower than it used to be.
That's probably good.
And motility might not be as good. They're a little bit dumber, so they like stop swimming and kind of futz around.
That sounds right too.
They're playing games and stuff like that. So the idea that I was getting at is that for the most part, I think people understand that you can fuck up DNA, and that can at least have an effect on your life.
Right.
If not, maybe not your kids, because it's unlikely for that genetic fuck up to actually get passed on to your kids.
Right.
But the reality is that because, as I mentioned, there's all these different kinds of cells out there and everything, it's clear that it's not just the DNA that decides what goes on. There must be all these other levels of control on top of that, including environmental regulation, right? As you interact with your environment, that changes what DNA gets read and how much protein it produces.
So there are things that we are possibly doing right now that are having epigenetic consequences on us.
Right. So this is where nature versus nurture comes in, is the question of nature being genetic. It's written in stone in your DNA, some aspect of you.
Right. Versus
nurture, which is the idea that, okay, the environment that you're in impacts you and like how you're raised and whether you were friends with like a derp when you were younger, like that kind of thing. And like you were saying, Lily, that nurture side is actually where epigenetics comes in. Because that's the interface between your DNA and your environment.
But then there's like nurture. Like if your dad's putting out cigarette butts on your hand being like, you don't get nothing for Christmas.
Well, but see, like that's the thing, is that like that seems like
it's double nurture.
That sounds like a really disastrous and f***ed up image to be giving our listeners so close to the holidays. But
well, this comes out after Christmas.
Yeah, good. Thank goodness, Nathan. Yeah. But that physical damage might actually have stress-related like DNA epigenetic effects.
Oh, such a snowflake.
Whoa, stress can have epigenetic, because like
that's a bummer. I think we're all a little stressed.
I don't like hearing that.
I don't know what gift to get Lily. My DNA's unbundling.
Yeah, okay. So basically, in the central dogma, I mentioned that there's the DNA, the RNA, the protein. Each one of those has an epigenetic control level.
Jesus.
Okay? And so you can control stuff on the protein level. It's called post-translational modifications. And so you can make it so that proteins will degrade faster or slower, so they'll stick around better. A lot of times, in cases of stress, there are kinds of physical stress where proteins get damaged. It's like when you're cooking an egg or something like that under hot temperatures or something.
Denatures.
Right. Wow, holy shit, dude. I'm so proud of you. Oh, you're a good boy today. You're a good boy. That's nice.
The only thing that brings a smile to my face is that one moment a week. That make you proud. Well, I'll make you proud, Sean.
Usually preceded by you bumming me out, but yeah.
I put that bar low. Donald Trump gives a speech without vomiting blood once. It's a good speech.
So proteins can denature and can be kind of refolded in the presence of chaperones. That's a kind of epigenetic control because it's a stress response to make it so your proteins last longer. And the same kinds of controls happen on the RNA level. You can make it so that RNA lasts longer, gets turned into more proteins, or gets degraded really fast. And then finally, you can also control things directly on the DNA level, just not changing the letters of the DNA, because that would be a genetic change. But you can change things like how tightly packed your DNA is. Because most of the time, DNA it's at a university. Have you been in like the main stacks of the library or something like that? And there's like shelves that are like hard to get to.
Yeah.
You gotta like
Sticky.
you gotta roll them out and everything like that.
Yeah.
And they're just like fucking really inaccessible.
I felt so smart whenever I did that. And I was getting a workout.
Yeah, wow, it's a twofer.
Yeah.
I always wanted to do like an Indiana Jones type of thing where somebody starts to like collapse the shelves in on me and I have to run through them before they get
I've
crushed.
always wanted to be the henchman who dies. I'm like right behind Lily, like, no!
You trip over your laces. No.
Drop the So yeah, basically, like I said, control on all these different kinds of levels. And the main impact is that, you know, you have these instructions in your DNA, but it doesn't get read all the time. And not even how often does it get read, but how many copies do you make? How much protein comes out of that gene? All of that is really what impacts how a cell behaves, how you interact with your environment, and how you deal with stress. Basically, every single part of our bodies is that step in between our DNA and then the actual proteins that do stuff.
Okay, quick pop science moment. Lily mentioned, can I eat quinoa to make my children models? Well, come on, Mr. Sean. Is there an example like that? Like, is there like, you put someone under a certain amount of stress, their kids are going to pop out like hunchbacks? Like, what's going on?
Okay, I can do that, but let's take a break for a commercial first, and then when we come back, I'll dive into what the consequences of epigenetics is.
Hi everyone, I'm Stacy Sang, the sound editor and designer for Petri Dish. I'm young, talented, and beautiful, and people are always asking me, how can I be more like you? You can't. But maybe you can be the best version of yourself this year with blood transfusions. It's a simple idea, folks. A tale as old as time. Get some young blood inside you. There's plenty out there. All that fresh and fragmented DNA floating around in your youthful blood will rejuvenate your entire body and empower your healing process. Every year, around this time, all you guilt-ridden honkies love to give to charity, maybe to a food bank or a children's shelter, because you want to feel like a good person, and you really want that tax write-off. Well, this year, let all those kids give back to you with blood transfusion.
And we're back. So basically, I want to start out by mentioning that epigenetics is a really broad term. So earlier, when Lily was kind of describing the idea of epigenetics, she brought up nature versus nurture. And both of the things that you said about it are true. That epigenetics does mean what all of the stuff on top of your actual genetic code, right? How your environment influences you. The reason why clones could end up being different or why twins are different. But then there's also that other part, the kind of part that's a little bit freakier. It made Nathan's face go all funky, right? The idea that the things that you do in your life might affect your kids and your grandkids.
Yeah.
And scientists actually disagree about whether or what of those things counts as epigenetics. So some scientists, there's like a nerd fight. Some scientists want it to mean the whole thing. Anything that's more than your DNA is epigenetics.
Anything that changes or affects your DNA is epigenetics.
Right. So long as it doesn't change the actual letters in your DNA, anything else.
Because if it changes the letters in your DNA, then it's a genetic mutation.
Yeah, it's
Right.
just
Right?
genetics.
Yeah. Yeah. And then there's some other scientists that are like, that's way too broad. They just want epigenetics to be about inheritance,
Right.
about passing it on to the next generations.
Right. Do we just listen to the Bible or do we have a larger institution? Fuck you guys!
So right now in the field, that specific epigenetics part, the one that's maybe more exciting, actually has its own kind of name, which is transgenerational epigenetics. It's
That
getting
is a
passed on.
mouthful.
Yeah. So transgenerational
Sexy mouthful. though.
epigenetic inheritance.
Transgenics. Oh my god. I should be like in the marketing for science.
There you go.
Chief Marketing Science Officer.
I'll buy stuff in that Swiss company. Okay, I'm a shareholder.
So one of the big questions is transgenerational epigenetic inheritance. Does that even exist? Is it real or not?
Wait, so what is transgenerational epigenetics? Hold on.
That's the one where things that happen in your life, like a famine or smoking cigarettes, or Nathan eating too much orange
I was
chicken.
about to say, use an example. Okay, yeah, you're right.
Yeah. Your disastrous
So good.
Hey, you.
orange chicken consumption.
This episode's devolved into a lot of personal attacks. My kids are going to be stronger and way more orange than your children, okay?
We've seen what orange does.
Oh,
On the
wow.
national stage.
That digs.
Oh, it's a Donald
That's
pet.
a dig. It's a Donald thing.
I was thinking about Orange is the New Black. And I was like, look, I don't love the show, but it has like a decent couple seasons. I was like,
You're probably the only person who would have gotten there. People
there's-
turning orange and not think of.
I was so confused. I was
45.
like, so because of what I eat, my daughter's a lesbian. She goes to jail. But
No,
she
isn't that Scientology?
she learns about herself.
So that is the transgenerational idea. The things that Nathan is doing in his personal life will be passed on to kids and grandkids.
Or the rest of the people here.
The human race.
Wouldn't that be so funny if it was actually a study of just me?
Yeah.
They're like, my God, unlike other people, his genes get passed down.
One thing I will say is that here's another nerd fight. There are some scientists who don't think that transgenerational epigenetics is real, that it happens at all.
Oh, interesting. Okay.
What those scientists argue is that everything people think is transgenerational epigenetics is actually what they call intergenerational. But the main thing there is it's about pregnancy. Stuff happening while you're pregnant affecting your kids and grandkids.
How
Sounds like
heterogenetic of them.
It sounds like a semantic argument.
Right, yeah. So in a certain sense, scientists end up they like to categorize stuff.
Right.
And
Yes.
because they care about mechanisms, you could kind of see how maybe these two things mechanistically are a little bit different. Because while you're pregnant, if you do something like smoking or drinking alcohol or something, those chemicals can directly affect the fetus.
Right.
Whereas if you are Nathan,
You can inherit epigenetic changes from your mom or your dad.
yes, so hypothetically, if the transgenerational thing is true, you should be able to inherit it from either one.
This is what's interesting for me on kind of a gendered level, is that we've been telling women that they can't do this or can't do that during pregnancy for basically the whole of human society, but it may turn out what men do also impacts what gets passed down. Transgenerational is about equality.
Yeah.
And for men, it's for longer. Looking
Right.
at the notes here, like for the ladies, it's really only while you're pregnant and afterward, and maybe breastfeeding? I don't know.
Right, so here's where it gets sort of mindfucky a little bit, right? Okay, because the question is, once you have a fetus or a baby or a child or something like that, those environmental factors
Right.
are affecting its DNA. So in that case, that's sort of like epigenetics definition 1.
Right, the broader field of epigenetics.
Right, just your environment influencing your epigenetics. When it's happening to the egg,
right.
or when it's happening to the sperm before you even form the fetus.
Now we're talking about trans-epi.
Now that's the transgenerational crazy one. That's the idea that, like, oh, it's happening so early. You could have dudes who, like as a teenager, you're a shithead and you do something. And then the idea is like, oh man, could that mistake from way back when still carry over to when you're having kids years later?
How would you even study that? Like, how would you know if that's a real thing?
Well, lucky for science, I gave some sperm to UC Berkeley when I was 12 as part of a Panda Express experiment. That's true! Reveal. I don't love Panda Express. I've done it for science this whole time.
The results are pending.
Yeah. When I'm 85, they'll take all my sperm.
Listen, oh boy. A sperm donation at a Panda Express is a really bleak image.
In the Panda Express. It's like instead of giving to kids.
You've taken it to a really
I
dark
think you've
place.
single-handedly tanked the sales.
Yeah, they're good pandas.
Tainted now.
I mean, if we were a proactive society, all guys would get some semen at 12 and freeze that. And then wouldn't matter after that, right? That's pre-Tide Pod.
Right, yeah. You'd get it locked down before you made your mistakes.
I think we've successfully clarified what transgenerational epigenetics
Right,
is.
but, Lily brought up a good question, which was, how can you study this? And,
Right.
and to be fair, that is one of the main reasons why there's some scientists who don't think it's real.
Right.
Is because there's a lot of these factors that start coming in that are like, okay, but how are you super sure that that wasn't just because of pregnancy? Right?
Right.
Like,
Yeah,
it's
and
just-
who wants to run tests on pregnant ladies? Like, who would even volunteer for that?
I think a I don't think we want the scientific community
Like,
to have to answer that.
I mean, but yeah, like seriously though, like if you wanted to track these changes or study them or see like what could and what does or doesn't have an effect, because ladies are told like, you know, don't drink alcohol or caffeine, don't smoke, and I mean, those
So you
are
have to
things
have a
that,
lady
like,
do all those things.
Like, well, I mean, those are like bad things that you probably shouldn't do a ton in general, but like, you know, it's a very strict sort of thing. How do we know which of them really will have a negative effect or won't? Because I don't know how you would study
Or a negative
pregnant
effect
lady.
on specifically
On your-
epigenetics. Right.
Yeah,
Yeah.
well, so those are all really great points. I mean, because another one that's really famous in epigenetics is stress. And telling a pregnant woman not to get stressed,
Yeah.
It's going to stress her out.
It just like borderline doesn't make any sense. You know
We
what I
have
mean?
like billion-dollar industries that are like focused around like helping us de-stress.
Yeah, so a lot of the studies that happen in epigenetics, a lot of the kind of earlier ones, were more like looking for associations after the fact. Like some kind of terrible thing happens
Right.
to pregnant women, and then years later looking at their kids versus kids that were born around the same time but without that terrible thing.
Right, but we have that problem coming in where we don't know the mechanism by which those changes are happening, so the study is faulty in its premise or its structure.
Right, so let's take, for example, this one called the Dutch Famine Data Set.
Ah,
Okay, so that's from 1944, 1945, the winter.
and they took the potatoes.
So are scientists just like waiting around for disasters, like natural disasters, to study?
Is this
people?
Nazi research time?
Like,
Somewhere there's a geneticist that's looking back in history books and reading something terrible happening and then being like, I hope I can find those kids.
That's
basically.
interesting.
oh,
So this is an after the fact study, right? They're looking at the kids decades later
Right.
and their kids decades later.
But what about the famous second Great Dutch Famine of 1956?
Right. Okay. But see, like, that's a really important point, actually.
Right.
Is that, like, there's a whole bunch of life that happens
Right.
in between you being born and then you having kids. What about all of those epigenetic influences?
You know,
yeah, it's a lot of variables.
One of the things that Sean's going to get to is that the result of the Dutch famine, in theory, is that there is a higher rate of cardiovascular disease amongst the children born in that generation. But Dutch food causes a higher rate of cardiovascular disease.
Yeah,
right?
if you're eating sticks of butter,
Yeah, a lot of variables in here.
maybe that.
Just like they're just like, put whole sticks of Gouda in their mouth, you know?
Right. So basically, what they tried to do is the Dutch famine data set is from women that were pregnant during that winter,
Right.
from 44 to 45. What they're comparing those kids and grandkids
Like
to,
43 to 44.
right, is
Yeah.
kids born right before or right after the famine.
Right.
Right.
Oh, okay.
And so their lives are mostly eating the same kind of Dutch food, you know, and
Just
like,
cod and
Yeah.
fucking herring.
right. Well, they're all sucking on the same stroop waffles.
Yep.
But yeah, like you were saying, is when you compare these kids that are really close in age, but the main difference is that, you know, kids in group A, their moms were pregnant during the famine, and kids in group B, their moms were pregnant right afterward. What you see is that these kids are more likely to be obese and have cardiovascular issues, and their kids are more likely to be obese and have cardiovascular
So this stuff
issues.
may have really passed down for a long time.
Right. But then the question is, again, is that
Right.
intergenerational? Because it was when the moms were pregnant.
I see.
Right? And
Whereas transgenerational will be more like the dudes.
right.
Maybe
Yeah.
their sperm sent some stuff.
Right. And so those are the kinds of harder things to dig into. And it's been really challenging. And a lot of the times what we've started doing is mouse studies. So using mice and then like freaking the dude mice out. Yeah, like hiding around corners and yeah, and making like Nathan shout at them and shit. And then once you've stressed those dude mice out, you can take their sperm and then impregnate these female mice that have been kind of kept all together and all under the same conditions. And so some of the female mice get stressed sperm and some of them get chilled out sperm from chilled out males. And then you can see how are those kids affected. And in that case, that really shouldn't be intergenerational because all the stressy shit happened before pregnancy, and during pregnancy, all of the female mice get kept the same. So in that case, you get to have a lot of control, and the main issue is that it's happening in mice and not people, and so, you know, how sure are you that that matters, right? But that's how you do those kinds of studies, and that's kind of more recently that we started doing them.
Oh, interesting.
So we've done a couple of them, and what we've found out is that kids that are born from stressed sperm have behavioral issues.
Okay, so are there any examples in people? that we can think of?
Mouse dress. You son of a
Mouse
bitch.
dress. Yeah, mouse dress.
Flowers for Algernon and me. Okay, tell me about
People
humans.
stress.
Yeah. So the example that I could find out there in the literature was that there's this disease called Prader-Willi syndrome.
I'm sorry. We've gone over the notes like a bunch of times too. It's just Willy. It's not even the word because it means a penis, but like when the way Sean says it.
God damn it. This is a legitimate disease that people have.
Tell me about Prader-Willi.
All right. Well, it's a genetic disease and it results in kind of mild to moderate mental impairment, weak muscle tone, compulsive eating. And usually it's because of a deletion of part of your chromosome 15. So like you got your X chromosomes, there's, a bunch of them. And one of them just has like a chunk missing. And that causes all kinds of problems. But when scientists were going around and there's a bunch of people with Prader-Willi and they were looking at their DNA, they found that some of them, a kind of small amount, actually seem to have all of the DNA they're supposed to. So they're not missing any part of chromosome 15, which goes against just sort of fundamentally the idea of what the disease is.
Right.
So,
what?
Yeah. Here's
They
where...
got meth in there.
Yeah.
Too much meth in these willies.
Yes, you read the
Holy
notes
shit.
about as deeply as you typically do.
Yeah.
The DNA was methylated, which is
Yeah.
a kind of epigenetic change that can happen to DNA. And it seems like this methylation was carried in the sperm.
Wait, what does that mean? What is DNA methylation?
Yeah,
Right.
It sounds like a metal band to me.
So a methyl group is a kind of chemical group. And these methyl groups can get attached to a lot of different kinds of things, but it also can be chemically attached onto your DNA.
Fuck.
And when it's attached onto your DNA, it's almost like a speed bump. Just like physically, it's in the way on that part of the DNA. It keeps that part of the DNA from being read.
Wait, DNA is physical?
Yeah, baby?
Oh.
It's the building blocks of life.
I thought these were all
Hello.
metaphors. I thought their soul was DNA.
So DNA is a physical thing. And I'm actually glad that you brought that up just briefly because I think that this is actually a really big disconnect for people. Is that cells are microscopic. DNA is something even smaller than your cells. All these things just sound kind of like words floating out there, not attached to anything.
This is real shit.
They're all physical things. And the way that all of them work is from them bumping into each other and then fucking doing something, okay? And so with DNA, for DNA to get read and do the whole central dogma thing, you physically need something to land on the DNA and kind of drive along the DNA, okay? And the methyl groups that get stuck onto the DNA are literally speed bumps that kind of send the car flying off the DNA. And then the DNA doesn't get read anymore.
Oh, wow.
So DNA that has a lot of methyl groups attached to it, that gene, a gene with a lot of methylation, no longer gets read anymore. So that's one form of epigenetic control.
What would cause that? Like, what would cause DNA methylation?
Right, so DNA methylation happens naturally through the course of development.
That's why when we get older, our DNA's all fucked up.
Like tanning and like
Well, yeah,
oxidative stress?
Yeah,
and the environment and
yeah.
shit?
In a certain sense, there are genes that are on when you are a fetus. There are genes that are turned on when you are a
interesting.
young child.
So sometimes your body methylates things on purpose.
Oh, yeah. Yes.
Oh,
And a lot of times it's for specific benefit because, for example, in some cancers, you see reduced methylation and more genes getting turned back on that normally are only on during fetal development.
Can I just say we had a beautiful Jimmy Coconuts moment where Sean said something and we, Lily and I, at the same time went, oh. Fucking juice right there, dude. That's the juice. That was OJ.
It was perfectly in sync.
Yeah, so basically, this DNA methylation is a normal process for controlling when different genes are able to be turned on and off. And it's probably the case that there are genes that get turned off that we kind of wish could stay turned on. For example, pretty much all babies have lactase as a gene so that they can digest their mother's milk. Most people in the world are lactose intolerant, not because they don't have the gene, but because it gets methylated.
Most people are lactose intolerant?
Yeah.
Is that just China, though?
Just like mild or like just mildly lactose intolerant?
Most-
Are there levels? Like if you have
There-
more methylation, then
There are
you even
levels.
look at a cow, you
That's
start
cool.
you get diarrhea.
There are levels.
9,000 methylation.
There are levels, and usually it's mainly Europeans and then a few groups in like Africa and the Middle East that are truly lactose tolerant. that have the lactase gene turned on full strength the whole time.
Interesting.
Yeah. And then most other people are varying degrees of lactose intolerant.
So, I mean, but then how is that not proof of transgenerational or intergenerational epigenetic? I mean, because, like, why would some people have that turned on and some people have that turned off? Like, what would cause that change or that discrepancy?
Dude, scientific breakthrough.
So that's a great
We're
question.
solving the problem right now.
The epigenetic change is itself controlled by another gene. So there's some gene that makes a protein. That protein does the methylation. And that other gene is mutated in people who are lactose tolerant. So it doesn't do as good a job methylating your lactase gene.
Oh, interesting.
So is it like we're not supposed to tolerate it? Like
Yeah.
that's the more natural,
Yes.
that's God's way, and
Yes.
then like
Wow. And then,
everyone
and then the
else-
white man.
Yeah, that's what fucking happened.
Is it
Because
like- what?
generally speaking, in sort of the course of a mammalian life, the main time you get milk is as a baby.
Right.
And then once you are big enough to kind of be able to eat leaves or fruit or whatever
That's
the fuck,
interesting.
then it's unnecessary to keep making that
Right.
enzyme.
Hunter-gatherers were not running around catching gazelle and sucking their nipples.
Yeah.
Right. Whereas once we domesticated animals, we started to get into that.
Right. Yes, exactly.
Milk is gross.
Yeah, but cheese isn't.
Yeah,
So-
but that was a mistake, right? Like, cheese is like a bunch of bros looking at old milk being like, you eat it.
Yeah. Holy shit, wait. Oh, yeah, DNA methylation.
Yeah.
Yeah. So, in Prader-Willi, what they saw was that the sperm from the father,
Whoa.
in these really rare cases, had some methylation that basically mimicked the same issue as having a chunk of your chromosome missing.
Oh, wow.
In that it was so methylated, you couldn't read any part of it, as if it wasn't there at all.
So these crackhead sperms get into the egg and just like fuck it all up.
Nathan's inciting race wars.
Whoa!
Meth head, my bad. Meth head.
Whoa.
I transcend race. Meth or crackhead.
There we go. Now that's equality.
Yeah.
Sure.
Equality.
Yeah.
So there you go, guys. There's your human example. I hope you enjoyed it.
Wow. So why do people just... I mean, I don't get it then. If, like, we just proved transgenerational epigenetic inheritance, what's up with the sticks in the mud?
Or
okay.
like what caused the sperm to be methylated in the first place?
Oh,
Right,
yeah.
Right. So that is a very good question, and that kind of spurs the rest of the issue, I guess, is that it's not clear in people what things cause methylation enough to make an issue in like a sperm or an egg.
Yeah.
And also what I should say is that in mammals, after the sperm and the egg meet up and you start to have a zygote, you're going to make a fetus and everything, there's 2 rounds of reprogramming that's supposed to just like get rid of all the methylation. Basically, as far as we knew, there are supposed to be specific events in the zygote, just fertilized, that's supposed to erase the epigenetics. You're supposed to start fresh. So the idea that there's any methylation left over from like the dad's sperm or anything is actually kind of controversial, because you can see in those zygotes that get fertilized, you can see all these things turning on to erase the epigenetics. So now what people think is that sometimes the erasure is not complete. Some stuff gets left over. And maybe some things get left over, kind of more likely to get left over than others. And maybe those are the changes that are transgenerational.
I didn't even know all that stuff was in a sperm.
Yeah.
Yeah.
I always thought a sperm was a little face.
Yeah.
Like a DNA, right? Like a little Homer Simpson.
Yeah. Go. Yeah.
It's all hitting each other.
Well, yeah, you're not actually alone. A lot of scientists also considered it that way. And what we're kind of finding out more is that the DNA that is in sperm does appear to have epigenetic changes. It's methylated in some parts.
Right.
The DNA gets wrapped around things called histones, and the sperm has different kinds of histone-like structures in it.
Wait, what the fuck is a histone?
Yeah.
A histone is kind of like, well, it's a protein.
Histone sounds like a spin-off of Drunk History, except you smoke weed first and then you tell the story. Right? Am I right? Am I right?
Because stone.
Yeah.
Yeah, histoned.
Wow. That was
Okay.
very powerful.
Get back to it, baby.
Okay. So, in your cells, your DNA is not just floating around willy-nilly.
Right.
It's usually actually packaged in a really specific way. And the way that packaging works is you take the DNA, which is the kind of double-stranded, ladder-looking kind of thing.
Right.
And then you wrap it around these little balls, basically.
Okay.
And so each ball gets kind of like 1.5 turns of DNA, and then you kind of string the balls on your DNA.
Right.
And then it gets packaged more and more.
And it's kind of like how people wrap up ropes. Some people have good technique. They wrap it properly, and it's really easy to unbundle. Some people just, like, fucking throw all the rope together, it gets knots, it gets all fucked up, and it's hard to untangle and actually use.
Right, and also, the way that histones kind of work for epigenetics is that you can wind the DNA so that the histones are really close together, and then there's almost no DNA that's unwrapped. Like, the space in between the histones. There's almost no space in between.
Oh, okay.
And
So
then
it can't be read.
Right, exactly. Yes.
Wow.
And so there's a whole fucking part of genetics and epigenetics that's just about histones and how histones get read or coded to make DNA wrapped tighter or not as tight. Like, there's like a whole fucking thing involved here. It's a big regulation pathway. But the point is that sperm kind of has their own sort of packaging. And then on top of that, we recently found out that sperm has certain kinds of RNA in it. And RNA is usually kind of thought of as like the middleman sort of dude in between DNA and protein. But now some scientists think that the RNA in sperm might be one of the main epigenetic transmitters.
I just wish I had a sexy young man like you to teach me biology when I was a kid. I would have been so into it. I actually kind of like biology, but the way you talk about histones is just so arousing. And I would have stayed awake all class.
Well, I appreciate that.
Lily and I both think you're very arousing.
But see, I think the interesting thing is that some of the stuff we're talking about with sperm transmitting epigenetic information is new. Like, past 5 years new.
Oh, wow.
So this is stuff that if you talk to some scientists, they would probably still say, no, sperm doesn't.
Well, it's like for the past fucking 500,000 years, ever since Australopithecus, we've been telling women, you gotta take care of your bodies, you're gonna make your baby bad. And it's the last 5 years we finally realized, hey, men too.
Yeah.
Men can fuck up their babies.
Hashtag men too.
Men too.
Is
Well,
that right?
that sounds.
Me too.
I haven't heard that, Ashley, but that sounds like a bad thing.
Yeah.
Well, this is a bad thing. It means that men need to
You
pay
just start
attention.
getting invitations from like the Proud Boys.
At least someone's listening, right?
We know who your audience
You
is.
need the votes to win. So, guys, we're going to take a break, and then we're going to talk about a lot of big picture shit. What are you doing that's going to epigenetically mess up all your grandchildren and children and all your whole fucking dynastic line?
The following is an actual advertisement.
Hello, friends. We are the Ladies of Strange. I'm Ashley.
I'm Tiffany. And I'm Rebecca.
Have you ever wondered if Ginny's head really did fall off when they removed the green ribbon?
Or if aliens are hiding in the tails of comets waiting to take us away?
Or if there's any scientific basis to the Ouija board?
Well, then don't risk your search history and join us each Thursday as we discuss
the history, mystery, and theory
of all things questionable, odd, and eerie.
New episodes are released every Thursday. You can find us on Apple Podcasts, Stitcher, Spotify, or wherever you listen to podcasts. More information about the show, including show notes and links to our social media, can be found on our website, theladiesofstrange.com.
Keep it strange, lovelies.
Epigenetic speculative fuckeries. Okay, wait, step back. Sean, I want you to wildly speculate on what are some other things that could epigenetically fuck you up.
Yeah, like what's messing up the sperms and the eggs and...
Especially sperm. Again, I'm tired of putting this on ladies. Men, your sperm's bad.
So again, I think it's actually right to focus on the sperm a little bit here because women
I always
already...
focus on that.
Whoa! No.
Yeah.
No,
Wait a minute.
I think
We've erased women from the conversation.
No, that's true because it does seem like for men, since it can kind of happen at any point in your life, statistically, there's just more possibility that you could be affecting your offspring.
Right.
But you could also be like fucking yourself up by doing certain things. You could be affecting your DNA.
Yes. From the perspective of epigenetics definition 1, there's a lot of things that we know affect your DNA in like the DNA methylation kind of thing. Smoking, for example. Smoking is known for a fact to cause widespread DNA methylation changes all over your body.
Wait, smoking is bad?
Yeah.
The anti-smoking lobby strikes again. What are they giving you, Sean?
Sponsorship.
Yeah, I'm paid by tobacco. It's going to be really weird where our first ad is like, don't smoke. Our second ad is like, for me, that's like, William Mass. Like, smoke more.
Yeah, so...
I also said William Morris, which is actually an entertainment agency.
Philip Morris.
Thank you. Okay, Sean, I'm sorry to interrupt.
There's something like smoking which definitely has DNA methylation issues that can happen. And I think that that's one of the reasons why it's like, okay, pregnant women shouldn't smoke. But I think now, as it's becoming more clear that maybe the sperm can transmit it too, it means, hey, dudes, maybe you shouldn't be smoking like ever.
Right.
Okay.
But it's so sexy.
That's true.
It looks so sexy. I mean, you seen Mad Men?
And you know, when I was in liberal arts school, the cool kids would smoke outside, and I'd just be like, doo 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 doo. It was like just like rolling main stacks together. It was very sad.
Just Charlie Brown walking away from them.
Yeah. Just all these footballs everywhere I couldn't kick. Pathetic, man. Just flopping over.
Yeah. I saw Dave Chappelle smoking on stage at SNL. It was very sexual.
Yeah.
Very sexual.
Great. He's bringing smoking back.
But look, don't smoke and just be an incel
But he's fucking
instead.
up his sperms.
I think he wants that now.
Yeah.
It's like instead of a vasectomy, he's just smoking more than he used to.
Pop the kids out first. How about that?
He already has two.
I know, that's what I mean.
And they're half Asian.
That's why he's doing it right.
Well, I think he was smoking during, too. But like, he's like, I'm gonna wait till I'm 42.
So the things that are more controversial are questions like diet and stress and exercise.
Okay, well, talk to me about stress.
Okay.
And exercise.
Yeah, actually, talk about all of them.
Yeah. These are all.
Yeah, these impact our lives.
Wait a minute.
Yeah.
Well, so it's just, the thing is that because of epigenetics definition 1, which is, hey, when your environment interacts with you, your body reacts to it by doing things like DNA methylation and histone modification. These things are reactions to your environment in kind of a really broad way, so that it's almost hard to imagine that eating things or exercising doesn't somehow affect your epigenetics. The question is whether or not it affects it enough to pass on something to your kids and your grandkids that'll like really impact them. So this is a mouse study, for example, but I think it almost flips the head on epigenetics a little bit, which is that in mice where the mice had a kind of liver damage, similar to cirrhosis from drinking too much, those mice's kids and grandkids, the male mouse drank too much. So the sperm
really
from
the
heavy drinking male mice.
Uh-oh.
The kids.
I see the way you look at me when you say heavy drinking mouse.
Well, you were downing a whole bottle of port earlier.
It's so smooth. I don't even like port. I just want to drink to forget.
So what they found was that the children of that generation and the grandchildren had changes in their livers to almost preemptively guard against liver damage.
Whoa, you're saying my alcoholism is going to protect my kids? No, wait, I'm not a man.
Yeah, it doesn't matter. Because your eggs are like, you got them in the vault. Right?
That is so sexist. Science is so ladies can't drink, and men can get sauced up, and they're just going to make super kids.
I feel like it's the opposite.
This
Is that like
is-
me saucing is going to mess up my sperm, and now that, like, there's 9 months where you can't be drinking, and otherwise fucking go to town, right? Because it's all, the eggs are in the vault.
No, it's you sacrifice your liver for your kids, and now your kids have like super livers.
Lily's take on this is correct.
No.
Now I want to say this was in mice. And
Nope.
this is also a great place to reiterate our disclaimer that we are not a medical podcast.
Oh.
So please,
Yeah,
no
I saw
one
you
take
wink
medical
though.
advice.
I
saw
feel
you
like,
when you said that.
we should be more specific. Maybe you and Lily aren't medical podcasters, but I am. Don't listen to them. You can take my advice.
Anyway, I wanted to bring up that example because I think that every time that we've talked about epigenetic changes, they've all been bad, right?
Right.
They've all been things like, oh, probably you shouldn't do this because it's going to fuck up your kids' lives.
But there's also the opposite.
Hypothetically, it should be the opposite too, right? Like some of these epigenetic changes, if they are passed on, they should be able to confer benefits sometimes.
Okay,
right?
well, list me your liberal namby-pamby cultural stuff that also apparently is good for science. What, like bicycling? Eating avocado? Only drinking seltzer water and occasionally White Claw? Well, that's good for kids, dick.
Well, see, now here's the problem, Nathan, is I don't have anything else on my list because we don't know yet.
Oh, okay.
These studies are too new. And we're not even sure if the mouse one holds up. It's just from one group, right? So I think the main thing here is that, epigenetics, it might come up more and more in the pop science realm. You might see articles about it in like New York Times Science or The Atlantic or something. But it reflects the reality that science is still hashing out whether these effects are big enough to actually get passed on. Because it's definitely the case. It's definitely the case that things like nutritional changes can alter your epigenetics in your body. It can have a positive effect on you, but it might not be a big enough magnitude to affect your grandkids or kids.
I feel like we should be doing like studies on like people who go on keto diets for a really long time or paleo diets for a really long time. Like, okay, so what happens to their kids? Because those are kind of extreme diets.
I feel like a lot of those people end up dying young, though, when they're on the bike lane, and then someone tries to turn. I don't think those guys make it.
So someday I think we're actually going to do an episode on some of those diets.
Right.
But I read an article recently on keto diets and how mice on keto diets, their kidneys get cured from like a kidney disease.
Oh my god, dude.
Oh,
and
no. Wait, keto's the one where I can just eat like bacon, right?
Yeah, it's protein and vegetables. It's like no carbs.
Paleo's the gross one because you can't like eat cooked stuff.
I'll be goddamned if I eat like a Kalahari Bushman. It's just not happening.
Yeah,
dude.
keto I feel like is protein and fat. I think
protein
is the
and
idea.
fat. I mean, I would miss bread, but
Yeah, not that much. You know what I'm saying?
Like it's just like, so I make sandwiches with hamburger patties. Oh, big deal.
Yeah. But yeah, the mice on this ketogenic diet were the symptoms of PKD, poly-something kidney disease, got alleviated. So it kind of helped fix up that disease. And I read that article and I was like, fuck. That's because now all these people that like keto are going to be asking like, oh, so keto is like legit. You know what I mean?
Well, that's what I was kind of worried about. It's like, we're not a medical or diet podcast. We're not necessarily endorsing keto. It's just this one study suggests, because I've heard multiple things about keto, right? Like, it's kind of the verdict is out about diets in general.
Yep. There's another question of like diets. How lasting are any of the changes? Because in some cases you do some kind of crazy diet or you do like caloric restriction or something, right?
Mm-hmm.
Where it's like you can only eat 1,000 calories a day and you can only eat 6 hours a day and all the rest of the time you have to be starving.
But maybe that trains epigenetically your fetus to be obese, right?
Yeah, could be.
Right.
Or like, and then like exercise, like studying people like marathoners who do like endurance, like extreme endurance training and like sprinters. Like it's very, very different. It taxes your body in a different way, works different muscle groups and everything. Even if you just look at marathon runners versus sprinters, sprinters are like big and marathon runners are really thin and lanky.
Poor mice. So we're going to do sprinting for some marathons?
Or we just study marathon runners and sprinters and their kids and see like if there are any differences.
I think there's going to be some studies that are coming out in the future of people who, for example, move to areas that are higher elevation. And see whether they have epigenetic changes.
Because you look at like Sherpas and shit.
Right.
And they're all like Neanderthal fucking breathe good, high up air.
Uh-oh.
What? No, isn't that true? It's like some of them bros got Neanderthal genes that make them good with cold and air stuff.
Yeah, I can't remember if
A
it's
lot of
Neanderthal,
people have
or,
Neanderthal
if it's,
genes, though.
or if it's Denisovan.
It's some it's some ancient fuckers.
Denisovan, I think, is like mostly in Asia, isn't it?
Well, it's like Asia. Isn't it like basically everyone who's not in Africa has a little bit Neanderthal? Like it's Eurasia in general.
Mostly Europe.
There's a part of Asia that has almost no Neanderthal and instead
Mm-hmm.
has a lot of Denisovan, which is another jabroni. Yeah. But anyway.
Well, let's talk about the big one, man. We gotta talk about stress still.
Yes.
Let's talk about stress.
It can cause a hormone in your body called cortisol to be released. And cortisol can go all over the place and cause immediate physiological effects. It can change your blood pressure. It can make you feel antsy. But aside from those direct physiological effects, it also signals within your cells to do things like cause epigenetic changes to your cells. So it's very clear. Cortisol causes epigenetic changes, and chronic stress makes those changes kind of get locked in more.
Oh, shit.
And the question now is like, does that even get into your sperm?
Right.
And get into that baby.
And from that mouse study we mentioned earlier, at least in mice, when you stress those mice out, however you're doing that, that gets locked in enough that you can see that in the kids.
And it causes behavioral.
Yeah.
It's fucked up.
It makes your kids kind of jittery.
Autism.
Have anxiety, basically. It was like mouse anxiety.
I work at a wine bar, which means alcoholism and stress all the time. High pressure work. My kids are gonna be little fuckers, dude.
But like we live in a time where everybody's stressed out. We spend a ton of money on things that are designed to de-stress because it's kind of uncontrollable. That's kind of scary, actually. This is stressing me out.
Yeah. So I guess this brings me to something I wanted to talk about sort of as a closing, is that parents are also stressed all the time, right? I mean, because you're afraid you're going to like fuck up your kid.
Not me, dude. My kid's going to be Bridget Terabithia. Just running around, maybe drowning, maybe not. I don't know, 50-50. That's a coin toss, dude. That's life. Okay, gotta learn some brutal shit.
You just talked about how you're stressed already.
I'm stressed about me? Okay, I don't care about the motherfuckers.
So, I guess what I'm trying to say is that I don't think that hyper-focusing on the potential epigenetic effects is good for anybody.
Right.
Because I do think that the most immediate cause is a combination of stress and a feeling of powerlessness.
Right.
Because there's too many potential environmental options.
Right.
And so I think, except for ones that are extremely clear, like smoking, which you should just avoid for a lot of health reasons, I think that broadly, the kind of lessons to take from epigenetics is that the things that were probably good for you for other reasons are probably also good for your epigenetics. It's like, oh, eat well.
Sure.
And exercise. And don't do naughty stuff.
This is back to the broader globalism of modern science. What? And how you're trying to force everyone to a certain type of cultural set of attitudes.
Oh my god.
Epstein lives.
Oh shit.
I had to get one last one in.
Yeah.
I'm sorry, guys.
Whew, fuck.
Yeah.
So,
all right. How about marijuana? Marijuana affect you epigenetically? That's the big question, right?
That is nah.
I'm gonna say maybe. We don't know yet. It's just research is curtailed in that because it's not in the U.S. federally.
It's literally only the last 5 years you realize that sperm swam into eggs. Right? like this is such a new field.
You son of a bitch.
We thought it was storks.
Oh my god.
Until like Trump got elected.
So broadly speaking, you're saying try your best to adopt kind of a healthy lifestyle. Don't like sit under x-rays or stand in front of the microwave. Is that a real thing?
How about cell phones?
Yeah. Ooh, great question. Yeah.
We're going to keep this episode going, baby.
It's very unlikely
okay,
that the electromagnetic radiation coming out of stuff like cell phones is going to have any meaningful effect on anything.
That's good, because I put that in a lot of places.
Yeah.
Okay, and I need those things to not be irritated.
Sometimes you stash it in between the cheeks. Yeah, and microwaves, as part of one of your other questions, actually have a little metal shield on them to prevent microwaves from popping out.
Okay, great.
On lifestyle changes and what is the important lesson to take away from epigenetics, I think you should definitely make those kinds of positive lifestyle changes, if only because we know they have good health effects. But also, just keep in the back of your mind, I think epigenetics will show up more and more in things that you might just like kind of read articles about. And so the reason why I think it's good that we did this episode, and something that I want people to take away, is that there might be epigenetic effects that can be passed on, but there's so much environmental stuff that impacts the rest of your life besides that impacts your epigenome. Like ignoring what your dad passed on to you or what you're going to pass on to your kids. There's all the rest of living that happens. Right. So I would put more attention on that.
Right. So much of the discourse right now is about either validating or rationalizing or debating good lifestyle habits, when you should just have good lifestyle habits, and it's going to have downstream effects on like basically everything.
Yeah.
I say that as someone who does none of it. Fuck that.
You were very convincing, though.
Yeah.
That was good. Just cut it and,
I thought I was talking to Mirror Nathan for a second. I was like,
yeah, a little goatee, but somehow also much healthier.
It's a deep fake.
Yeah. That Mirror Nathan is still evil. He's just maximizing himself.
All right. So I think we should say thank you. Thank you to Lily for bringing this topic up with us and hanging out and recording the episode with us.
Yeah, thanks for having me.
Thank you to Stacy, our sound lord and engineer, and Brian Allen for art.
Yeah, you can contact us at Dish Podcast on Twitter, and you can email us at petridishpod@gmail.com.
Jimmy Coconuts 2020.
Oh, okay.
Yeah, just official pod endorsement.
Tossing his hat in the ring. Okay.
Well, actually, this is a good point to mention something, which is that when there's a little disclaimer before commercial and Stacy comes on and says it's real, it's actually real.
All Stacy disclaimers are legitimate.
Yeah. Anything Nathan and I say could be some kind of joke. Stacy is always serious.
And the following ad is a real ad that you should really pay attention to and has great content.
Yeah. So, thank you guys for listening, and hopefully we'll have you guys listening again soon.
If benign science.
Da